right, and next we have Carlos Vicente, who's going to talk about network automation and tools.
Thank you. Where is the clicker? This one? Next, okay. So first of all, the name of the talk is Automatically Build, Test, and Deploy Your Network Configurations. Who here has seen this cartoon character, Kipper? I love Kipper because I want to be like Kipper. He's a very mellow dog, and he likes an easy, simple life. And I guess the real question, the real test for network automation is whether it can do that for us, network engineers. Can we have a simpler life? I think so. What are the problems we're facing today is many of us are too used to handcrafting our configurations and copy-pasting from here to there, and it's just bad. I mean, you can always figure out which device you copied a configuration from because you always miss something, right? And it leads to inconsistencies, and over time you have a network where nothing is the same, and that's a problem. You need to make a change across every device. It takes forever because you have to figure out every single difference and take it into account. It just doesn't scale, so we want to move away from that. The other problem is we normally don't have a formal approval process. We are sitting in front of the CLI, and we decide that that's the right configuration that has to be in there, and we commit it, if we have even commit operations. We want something better than that. We want some kind of review process, and we want that to be formal. So some of the goals we had when we started this project called Kipper was we want to facilitate this consistency, and of course you do that by using templates, and it's something that some people have been doing forever. I remember at the University of Oregon we used to use M4 macros. The ones used for SendMail. Maybe you're not. Yeah, Joel remembers. So yeah, templates. Templates allow you to have things that are standard, that are accurate, and predictable. Of course, we want to minimize errors. We don't want to think at the CLI. We want to have a smarter system. And we want reviews and approvals, and we want automated tests. That's a very important thing. We want tests to happen automatically. And we want to increase speed. We want things happen to be able to change things faster. More goals we had were, of course, use open source if possible, use open standards if possible, for the obvious reasons. And what can we do? We can learn from software engineers. They've been automating for the longest time. They have this concept called continuous integration, continuous delivery, CI/CD. And the idea is there's many people working on the same code in their own little things, and they integrate those changes frequently so that it's easier to deal with problems early on instead of waiting days later when a lot of code has to be merged. They do this, and they automate the build, the test, and the deploy process of this. And that allows them to identify errors very quickly. And there's many tools available that help with that. One of them is Jenkins, which we'll talk about. The other group we can learn from is sysadmins. They've been managing hundreds of servers or thousands of servers, and they've figured out that there are some good tools out there that they can use, or they've actually written these tools, like Chef, Puppet, Ansible, Salt. And these are nothing more than domain-specific languages that allow them to specify the state that they want the particular thing to be in. And they combine that with version control so that they can have a way to go back if something breaks, and a way to see where something broke exactly and who broke it. Oops. Okay. The problem is these concepts and processes are, for the most part, very much missing from networks. Why? Well, because it's hard, and we haven't had the right tools until now. But things are improving. The case of Dyn is we have about 20 data centers around the world in 5 continents. We have hundreds of network devices, and we have multiple teams that need to touch these devices. We have system administrators, automation, network people, et cetera, et cetera. And the company is growing fast, and so automation has been a main priority. And we've had, and we continue to improve automation on servers and applications, but as of last year, we pretty much didn't have any network automation. So speaking of open standards, in terms of network configuration management, we have pretty much the only thing is NetConf. It has many cool things, but one of them is the idea of a candidate configuration. We have this idea of transactions, and there's this candidate database that we work on without affecting the operation of the device, and then we can compare that candidate database with a real database that's in production. It can use SSH as a secure transport. Almost everything speaks SSH these days. And one good thing is that there's good support on Juniper, probably because they were very much involved in the standardization process of NetConf. But the problem is it's not so much available in other platforms, and that's not so good. Ansible is one of those configuration management tools that I mentioned, and it has some great things. One of them is that it's focused on simplicity. It's easier to learn Ansible than some of the other ones. And it's agentless, meaning that you don't need to install a piece of code or an agent in your network device, and that's very important. It uses SSH to communicate. It uses the push model as opposed to the pull model, and I like that because I feel like I have more control on when things happen and the timing of these changes. And one great thing is that it's modular. You can write your own modules and make it do different things. And fortunately, Juniper wrote a module for Ansible that implements NetConf. And so you can have Ansible speak to your network using NetConf. GitHub, everybody's heard about GitHub. It's based on Git, version control, has a web interface. It has some very cool features like forks, pull requests, things like gists, where you can post little snippets of things and make them look pretty, and they have a URL, and other good things about them. Of course, you're not going to put your network configurations on GitHub, on the public GitHub, but for a fee, you can keep them private, or you can run your own appliance. The other tool is Jenkins, and this one is used. It's very popular. It's open source, very popular among software developers. And it's basically a web-based tool that integrates with other things in a way that allows you to execute code when things happen, events. And these events can come from any of the integrations that Jenkins has. In our case, we use it and we integrate it with GitHub. So when a pull request happens, we can make Jenkins do something. When a merge happens, we can make Jenkins do something. Now, if you have to pay attention to one slide in this talk, this would be the one. So pay attention. This is the workflow we've built using these tools and concepts. You have engineers. They all have a copy of the repository for making network changes. And we have a smaller group of administrators that have some higher control on what happens. So let's say this engineer makes some changes, and he or she sends a pull request via GitHub. This pull request causes GitHub to send a notification to the Kipper server, which is nothing more than a Linux box running Ansible and Jenkins. It basically tells Jenkins, here, there's a new pull request, and here are all the details about it. Jenkins downloads the latest copy of the repository. It merges the code from the pull request. It builds the configurations using templates. And it sends a test, a dry run, to the network. It doesn't actually commit anything, but it sends a dry run to the network. And it says, tell me, does this run? Does this have any syntax problems? And if there are any changes, I want to know exactly what's changing in the device. So you get back a diff. You send that diff, you put it in a gist, and you send the URL to the administrators and the engineers, and they look at what's going on, and they see, yeah, well, that makes sense. I don't think that's going to break anything, and I know now that the syntax is OK. And so if everything looks fine, the administrator approves by merging the code, the pull request. When the merge happens, another event is triggered in Jenkins, and it optionally can release a new version of the configuration for the whole network, and eventually send the configurations to the network, now for real. Notice that nobody's at the CLI at this point. And everything that came out of Kipper was generated by a template. The way things are organized is there's an inventory file that has all the device grouped by functions and by location. So you group all your routers that are edge routers in one group, and all your routers that are, I don't know, whatever. And then you keep all the other stuff, all the stuff that's in one location in another group. Why? Because things that are in those groups have common things, right? Things that are of, edge routers have very many things in common, and things that are in a location have things in common. So you use those commonalities and those groups to let Ansible be smarter about how the templates are rendered. Use variables that apply to either groups or individual nodes, and you tie those things together in things called roles. This is an example of a variable file, and the format is YAML, yet another meta language, I think. And it's basically text, key value pairs, and lists, and they can be nested lists, etc. So it's very easy to read, easy to edit. And you can notice that we have two directories there. One is group variables, and there's one called all, and those variables apply to everything. So you have things that are the same everywhere. And you have things that are the same in Amsterdam, or you have things that are the same in Ashburn, etc. And then you have host variables that are the things that are very particular to that router. Now, templates in Ansible use something called Jinja 2, which it's nothing more than, it's basically Python and text, text with embedded Python, and you can have conditionals and loops. And now, this is important. We used XML as the format of our configuration descriptions. Why? Well, first thing, because we had to. It turns out that XML is better, is supported across many different versions of Juno, so it makes our life easier. But most importantly, XML is very easy to parse with code. And you can load the final configuration into a data structure, and then you can do very cool things, like make sure that all my interface descriptions follow the convention. Make sure that all my BGP sessions have MD5 passwords. Make sure that all my transit, my connections to transit and peering have arrays disabled for IPv6, et cetera, et cetera. So the possibilities are, endless. You just need to write some simple code. This is an example of a template. You have XML with variables that are interpolated, and you have for loops, and you have conditionals. And if this happens, do this. If this other thing happens, do that. And here's the build process in a diagram. The way this works is Ansible connects to the network with NetConf, and it gets facts. What are these facts? They're the version of the operating system, the model, etc. Things that are useful when you're building these configurations, when you're parsing or not parsing, rendering these templates. You take those facts and you combine them with the variables that you've edited. And in this example, you have two services. You have SNMP configuration and you have system parameters. So I have variables for each one of those. And I feed those variables and those facts to the templates, one for each service. And those templates come out and generate little snippets of configuration in XML. And finally, we take all those and put them together into one XML file. And at the end, then you can do your validation. You can run all the little scripts that check for all your policies. The test is, as I mentioned earlier, it's a commit check in Junos. It sends the configuration to the device, but it says, just don't put this into the actual running database. Just put it into your candidate database and tell me if it looks OK, and tell me what would change by comparing it with what's running. Or tell me if there are any errors. And you send those back to the administrators. And the deploy process is basically just committing that. And you can do things additionally to committing. For example, you can run rancid, or you can send notifications to the NOC telling them that something's changing. So all that said, you tell me, Carlos, I have thousands or hundreds of devices, and it's a big mess. How do I start? Where do I start? How do I tackle this problem? Well, as with anything that's complicated, start simple. Look at all the most common parts of your configurations. Maybe your NTP servers are mostly the same everywhere. DNS, SNMP, prefix lists that are common everywhere. And you take those things that are easy to do, quick gains, and you build templates for them. And you work incrementally towards 100% coverage of the configuration with templates. And then the great thing is your template becomes your policy. And you can do dry runs periodically, let's say a few times a day, comparing what the template says that the network should have with what the network actually has. And you can send notifications and say, what do we do here? Do we modify the template, or do we modify the network to go back to where it should be? The challenge is, as with anything, it's a cultural change. It requires us to think differently. We no longer can, quickly sit at the CLI and, a quick fix. I can do this in 2 minutes. Well, maybe you need to spend a little more time and build a template, and it's a bit of an investment, and you just do a bit more work up front, and then you'll greatly benefit later, because it's later on, the template is going to drive the thing, and it's going to make it all the same. Another little nuisance is that sometimes the dry runs fail because someone is at the CLI making a change and they have the lock. And so Ansible complains that it can't modify the device because it's someone's using it. And that's just a little problem until everything is covered by templates. You just have to run the pull request again. The other issue is if you really want to have tight control and you want just a few people to decide whether a change is merged, then you have the issue of off hours. I mean, what if you have an on-call person that is not an administrator that needs to make a change really quickly because there's an attack? What do? Do you wake up the administrator? Maybe not. But it's a matter of thinking about permissions and how you want to do that in your own case. Other limitations, the main limitation here is if you have a multi-vendor environment, this is a little harder because the APIs are not standard. Will they ever be? I hope so, but I'm not so sure. Hopefully this will create maybe more demand for that, and vendors will listen to us. Looking ahead, these tools are okay for now, but there will be better tools. And there's this person called Jeremy Schulman who did a lot of this work at Juniper. Who founded his own company called Sprockets, and he thinks he can do a better job, and he's building something that looks like Ansible, but is more network focused. From what I hear, he's solving the problem of the multiple APIs by adding those integrations into the tool, so that he has integrations for NetConf, and he can deal with the different APIs, and you probably won't have to deal with them. And yeah, things might change. I mean, this is the solution for the problem we have now. But some trends that we're observing, for example, we're going more towards open platforms where software is not tied to the hardware. And so we won't be dealing with these black boxes anymore. And so maybe the need for a common API is not as relevant. We also see the trend of overlay versus underlay networks, where the underlying network, legacy network, is very static and it doesn't change anymore as much. And then some of the intelligence has been pushed to the hypervisor that runs all the virtualization, and that's where a lot of the change happens. So these problems might change in the future, and we'll deal with them as they come. The final thing I wanted to add was a note on network design. Automation is great, and we feel the urge to automate more and more. But one thing we need to ask ourselves is, can I even avoid touching the network in the first place? Because if I can achieve that, then it's better. One thing to think about, really, which is very important, is there a tight coupling between my servers, my services, and my network? When I make a change in a service or a server, do I need to touch the network too? And if so, there is tight coupling, and I need to think about how to avoid that. Maybe use more routing protocols. Push the security more down to the server, et cetera, et cetera. So you don't have to be touching the network so much. So just design with that in mind. And in the spirit of sharing, I put together this repository in GitHub where you can use the same Ansible playbooks with some generic data and a couple of templates that will give you an idea how to use this yourselves, and hopefully it'll be useful. And maybe you'll look at them and tell me that I'm doing it all wrong and that I really don't know Ansible and I can do it in 3 lines instead of 10. That would be great. So that is it. We have some time for questions, I think.
Hi, this is Andre with OpenDNS. I have a question. Have you thought about extending the test framework with just a diff and maybe spinning up all of instances, or wondering what your thoughts are?
Yeah, ideally you would test in a staging environment, and that could be that you have a separate data center where you have a replica of everything that you have everywhere else. So ideally, you would put that into the workflow. Apply these in the staging environment first, and let's make sure that doesn't break. Alternatively, you can virtualize it, and you can find more and more resources for that. Junos has had a virtual SRX box for a long time, and now I believe they have an MX version of that. And so eventually you should be able to virtualize a test environment that would be useful. I hope I'm answering your question.
Tony Tauber, Comcast. how many vendors support this commit check type of function that you talked about?
I honestly only have experience with Junos. However, the NetConf standard has it in there. So if the vendor supports NetConf, but maybe some of the other APIs, maybe Arista and the other APIs that are proprietary also have this feature.
And is that the way, so you had a validation step in there. Is that the only way that you have currently to do that, or do you have other things that you've found?
Yeah, so the test is two things. The test is the code you run on the data, on the configuration structure, to make sure that it follows some policy that you define. And the other is making sure that the commit passes syntax checks and that you see what is going to change exactly. That's
Right,
pretty
and
much
so
it.
the way, just so I'm clear, the way you're doing the syntax check is the commit check, or there's
No, it happens. If the engineer is running Ansible in their workstation, they can actually run some of those checks locally before they even get to the network. The policy checks.
Okay, thanks.
One more.
Hi, Eric from Amsterdam Internet Exchange. I just want to ask you, how do you keep track of your equipment? Say, how do you build the database of your equipment?
A database of your equipment. When I was at the University of Oregon, we wrote something called NetDot that uses SNMP to discover the whole network, and it puts it all into a database, and it's very detailed, and you have a lot of information about what the device is and the interfaces and everything. And it's an open source, so you can use that, for example.
Yeah, but it's just like collecting information from network equipment. But are you also using it for like provisioning?
Yeah, that's a great question. Not yet, but we could feed Ansible, instead of having a text inventory file, that inventory can come from a database. And that's something I want to do.
Okay.
And the database would be, either NetDot or something else.
Okay.
Joel Yeagley. So you reminded me of something, of course, because my first experiment with configuration automation was Dave Meyer's M4 macros for building Cisco configs, which basically ruined me on this idea for about a decade. But I think in the interim, like, a lot of stuff has happened. I mean, I think we used to see this as a source of competitive advantage if your organization could actually do this. At this point, it's basically all I can do to keep from falling behind. That we, step up our game on automation. And I think one of the interesting things that our industry is faced with is that we all do this slightly differently. And if it's no longer a source of competitive advantage, there are economies of scale to be reaped if we all do it in a relatively similar fashion. So I definitely applaud talking about it. Thanks.
Thank you. Okay. Thanks for listening, and enjoy the day.